On this video, we're going to talk about all the derivative rules you know up to this point, starting with the definition of the derivative. So the derivative of f with respect to x is the limit as h goes to 0 of f of x plus h minus f of x divided by h. So don't forget about this one. We can always go back here. And this is where all of our derivative rules originate. So we're going to talk about all of the other ones we have, and then in further videos, I'll do examples. So here are our shortcuts. Let's start with the simplest one, the derivative of c, where c is a constant. The derivative of any constant is 0. So this is our derivative of a constant function. Okay? Remember, the picture of this is that if we have a constant function, its graph is a horizontal line, and the slope of every horizontal line is 0. Secondly, we're going to take the derivative of x to the n. Remember this notation here? This d over dx means take the derivative. And the function that we're taking the derivative of is x to the n. Okay, that d over dx means take the derivative. Take the derivative with respect to x. Down here tells us what we're taking the derivative with respect to. Okay, so if we take the derivative of x to the n, we get n times x to the n minus 1. This is our power rule. So this works well when we have a function like x squared. Okay, but it does not work if our function is 2 to the x. So x squared looks similar to 2 to the x. The difference is that the base and the exponent are switched. So 2 to the x, that's an exponential function. X squared is a power function. So the power rule only works for power functions. We also need to know how to find the derivative of 2 to the x. Well, let's figure it out. The derivative of a to the x, where a to the x here is an exponential function. So we want a to be greater than 0 and a to not equal 1. So this part is in section 3.2 in the book. This is the natural log of a times a to the x. It's the natural log of a times a to the x. Okay, so let's just go ahead and say this is our exponential function rule. It's our derivative of exponential functions. So if we wanted to take the derivative of a very special exponential function, e to the x, we would get the natural log of e times e to the x, and of course the natural log of e is 1, so we get e to the x. A very nice function to take the derivative of. The derivative of e to the x is just itself, e to the x. Okay. Instead, if we wanted to take the derivative of 2 to the x, which was on our last slide, the derivative of 2 to the x is the natural log of 2 times 2 to the x. Okay, and section 3.2 talks about why this is. All right, if we take the derivative of c times f of x, where c is a constant, the derivative of something like 2 times f of x, or the derivative of square root of 5 times f of x. This is the same thing as just leaving that constant alone, pulling it out in front, and taking the derivative of f of x itself. So the derivative of c times f of x is c times the derivative of f. Okay, this is called our constant multiple rule. And I want you to realize that this only works if c is a constant. It does not work if c is an expression with an x in it. So I cannot use this constant multiple rule if c has an x in it at all, or if it's x. The derivative of x times f of x is not x times f prime of x. It only works if c is a constant. And our last rule is I want to take the derivative of two functions that I'm adding together, the derivative of f of x plus the derivative of g of x. So if you want to take the derivative of a sum of two functions, It is just the derivative of the first one plus the derivative of the second one. So the derivative of f of x plus the derivative of g of x is f prime of x plus g prime of x. And so in the subsequent videos, I'll do examples of each one of these derivative rules.